Introduction. Good morning, teacher. Good morning, students. Who will tell me when the function is said to be continuous? Sir, a function is said to be continuous if the right-hand limit, left-hand limit and the value of function all are equal. Very good, Ishan. Sir, can you please tell us about differentiation? Sure. Differentiation is the rate of change of functions. Differentiation is a very important tool for study of various functions. Sir, can we differentiate any function? Yes, but there are some rules. If the function follows those rules, then we can differentiate the function. In this lesson, you will learn continuity and differentiability of the functions. Objectives. At the end of this lesson, you will be able to check that the function is continuous or not. Check that the function is continuous or not in an open and closed interval. Apply algebraic operations on continuous functions. Find the differentiation of the composite functions. Find the differentiation of the implicit functions. Find the differentiation of the inverse trigonometric functions. Find the differentiation of the exponential and logarithmic functions. Find the derivatives of functions in parametric forms. Find second-order derivatives. State mean value theorem. Check that the function is satisfying mean value theorem or not. Continuity. A function f(x) is said to be continuous at an interior point x is equal to a, or its domain if limit x tends to a, f of x is equal to f of a. In other words, a function f of x is said to be continuous at a point x is equal to a, provided left-hand limit, right-hand limit and the value of function are equal. Limit h approaches to 0 of f of a minus h is equal to limit h approaches to 0 of f of a plus h is equal to f of a. For example, y is equal to sin x is a continuous function. If f is not continuous at a, then f is discontinuous at a, then a is called a point of discontinuity of f. Example. Consider the function f of x is equal to 5x minus 4 if 0 is less than x less than or equal to 2, is equal to 4x cube minus 3x if 1 is less than x is less than 2. Check whether f of x is continuous or not. Solution. At x is equal to 1. Left-hand limit is equal to limit x approaches 1 minus f of x is equal to limit x approaches 1 minus 5x minus 4. Put x is equal to 1 minus h. As x approaches 1 minus, h approaches 0. Therefore, left-hand limit is equal to limit h approaches 0, 5 into 1 minus h minus 4 is equal to 5 into 1 minus 0 minus 4 is equal to 1. Right-hand limit is equal to limit x approaches 1 plus f of x is equal to limit x approaches 1 plus 4x cube minus 3x. Put x is equal to 1 plus h, as x approaches 1 plus h approaches 0. Therefore, right-hand limit is equal to limit h approaches 0 of 4 into 1 minus h cube minus 3 into 1 plus h is equal to 4 into 1 plus 0 cube minus 3 into 1 plus 0 is equal to 1. F of 1 is equal to 5 into 1 minus 4 is equal to 1. Since left-hand limit is equal to right-hand limit is equal to f of 1. Therefore, f of x is continuous at x is equal to 1. Continuity. Continuity on an open interval. A function f of x is said to be continuous on an open interval a, b if it is continuous at each point of a, b. Continuity on a closed interval. A function f of x is said to be continuous on a closed interval a, b if 1. F of x is continuous from right at x is equal to a. That is, limit h approaches 0 of f of a plus h is equal to f of a. 2. F of x is continuous from left at x is equal to b. That is, limit h approaches 0 of f of b minus h is equal to f of b. 3. F of x is continuous at each point of the open interval a, b. Example. Consider the function f of x is equal to x square, x is greater than 0, is equal to x is less than or equal to 0. Check whether f of x is continuous or not. Solution. When x is greater than 0, f of x is equal to x square, which being a polynomial function is continuous. When x is less than 0, f of x is equal to x, which being an identity function is continuous. Now only doubtful point is x is equal to 0. Left-hand limit. Limit h approaches 0 minus of f of x is equal to limit x approaches 0 minus of x. Put x is equal to 0 minus h, as x approaches 0 minus h approaches 0. Left-hand limit is equal to limit h approaches 0 of 0 minus h is equal to 0 minus 0 is equal to 0. Right-hand limit is equal to limit x approaches 0 plus of f of x is equal to limit x approaches 0 plus of x square. Put x is equal to 0 plus h, as x approaches 0 plus h approaches 0. Right-hand limit is equal to limit h approaches 0 of 0 plus h square is equal to 0 plus 0 square is equal to 0. Now, f of 0 is equal to 0. Since left-hand limit is equal to right-hand limit is equal to f of 0, f of x is continuous at x is equal to 0. Therefore, f of x is continuous function. Continuity. Concept of infinity. let us plot the graph of fx is equal to 1 by x in the neighborhood of x is equal to 0. For x is equal to 1, f of x is equal to 1. For x is equal to 0.5, f of x is equal to 2. For x is equal to 0.1, f of x is equal to 10. For x is equal to 0.01, f of x is equal to 100, and so on. It is observed that as x gets closer to 0 from the right, the value of fx becomes larger and larger. Thus, the value of f of x becomes very large as x is chosen as very close to 0. Symbolically, we write it as limit x approaches 0 plus of f of x is equal to plus infinity. When we approach f of x from left near x is equal to 0, then we get limit x approaches 0 minus of f of x is equal to minus infinity. From graph, we can observe that as x approaches 0 plus, the graph meets y-axis at plus infinity. Similarly, as x approaches 0 minus, the graph meets y-axis at minus infinity. Algebra of continuous function. Theorem 1. Suppose f and g be two real functions continuous at a real number a, then 1. F plus g is continuous at x is equal to a. 2. F minus g is continuous at x is equal to a. 3. F into g is continuous at x is equal to a. 4. F by g is continuous at x is equal to a. Ga not equals to 0. Theorem 2. Suppose f and g are real valued functions such that f of g is defined at a. If g is continuous at a and if f is continuous at g of a, then f of g is continuous at a. Example. Let f of x is equal to 2x minus 1 and g of x is equal to x plus 5 by 2. Find the function f of gx. Solution. Given g of x is equal to x plus 5 by 2. So, f of gx is equal to f of gx is equal to f of x plus 5 by 2 is equal to 2 into x plus 5 by 2 minus 1 is equal to x plus 5 minus 1 is equal to x plus 4. Differentiability. Let f is a real function and a is a point in its domain. If h is a small arbitrary number, the derivative of f at a is defined by limit h approaches 0 of f of a plus h minus f of a divided by h. Provided this limit exists, derivative of f at a is denoted by f dash a or d by dx of f of x at x is equal to a. The function defined by f dash x is equal to limit h approaches 0 of f of x plus h minus f of x divided by h. The process of finding derivative of a function is called differentiation. The function is differentiable at a point a in its domain if both the limits, that is, left-hand limit and right-hand limit, are finite and equal. Theorem. If a function f is differentiable at a point A, then it is also continuous at that point. Differentiability. Formulas. d by dx of u plus minus v plus minus w plus minus and so on is equal to d by dx of u plus minus d by dx of v plus minus d by dx of w plus minus and so on. d by dx of u into v is equal to u into d by dx of v plus v into d by dx of u. d by dx of u by v is equal to v into d by dx of u minus u into d by dx of v divided by v square. Differentiation of some important functions. 1. d by dx of constant is equal to 0. 2. d by dx of x raised to power n is equal to n into x raised to power n minus 1. 3. d by dx of sin x is equal to cos x. 4. d by dx of cos x is equal to minus sin x. 5. d by dx of tan x is equal to sec square x. 6. d by dx of cosec x is equal to minus cosec x into cot x. 7. d by dx of sec x is equal to sec x into tan x. 8. d by dx of cot x is equal to minus cosec square x. Derivative of composite function. Let y is equal to f of t and t is equal to g of x, where f and g are both differentiable functions. Then y is equal to f of gx is a function of x and is also differentiable. We can write d by dx of y is equal to d by dt of y into d by dx of t. This method of differentiation is also known as chain rule. Example. Find the derivative of the function f of x is equal to cos of x square. Solution. The given function is a composite of two functions. Let t is equal to x square and v of t is equal to cos t. Differentiating t with respect to x. d by dx of t is equal to 2x. Differentiating v of t with respect to t. d by dt of v is equal to d by dt of cos t is equal to minus sin t. Hence, by chain rule, d by dx of f is equal to d by dt of v into d by dx of t is equal to minus sin x square into 2x. Put the value of t is equal to x square is equal to minus sin x square into 2x is equal to minus 2x into sin x square dot 2x. Derivative of implicit functions. Find dy by dx when x square plus x square y plus xy square plus y cube is equal to 47. Solution. Given x square plus x square into y plus x into y square plus y cube is equal to 47. Differentiating with respect to x, we get 2x plus 2xy plus x square into dy by dx plus y square plus x into 2y dy by dx plus 3 into y square dy by dx is equal to 0. Transfer the terms without dy by dx to the right-hand side and taking common dy by dx from the left-hand side, we get dy by dx into x square plus 2 into x into y plus 3 into y square is equal to minus 2 into x minus 2 into x into y minus y square. Dy by dx is equal to minus of 2 into x plus 2 into x into y plus y square divided by x square plus 2 into x into y plus 3 into y square. Graphs of inverse trigonometric functions. Graph of sine raised to power minus 1 x. Graph of cos raised to power minus 1 x. Example. Find the derivative of f given by f of x is equal to cos inverse x assuming it exists. Solution. Let y is equal to cos inverse x. X is equal to cos y. Differentiating both sides with respect to x, we get 1 is equal to minus sin y into dy by dx. dy by dx is equal to minus 1 by sin y. Observe that dy by dx is defined only if sin y not equals to 0. That is, y belongs to 0, pi. It implies sin y greater than 0. It implies sin y is equal to square root of 1 minus cos square y. dy by dx is equal to minus 1 by square root 1 minus cos square y is equal to minus 1 by square root 1 minus x square. Exponential and logarithmic functions. Exponential function with base 10 is called the common exponential function. The derivative of e raised to the power x with respect to x is e raised to the power, that is, d by dx of e raised to the power x is equal to e raised to the power x. 1. The sum of infinite series. 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus so on is denoted by e. 2. The approximate value of e is 2.7183. It is an irrational number. 3. The value of e raised to the power 0 is equal to 1. Using this e as the base, then we get exponential function y is equal to e raised to the power x. This is called natural exponential function. The plot of y is equal to e raised to the power x and y is equal to log x to the base e are the mirror images of each other. Logarithmic functions. The derivative of log x with respect to x is 1 by x, that is, d by dx of log x is equal to 1 by x. Properties of logarithmic functions. 1. log mn to the base a is equal to log m to the base a plus log n to the base a. 2. Log m by n to the base a is equal to log m to the base a minus log n to the base a. 3. Log m raised to the power n to the base a is equal to n into log m to the base a. 4. Log m to the base a is equal to log m to the base b into log b to the base a. Example: differentiate e raised to the power sin x with respect to x. Solution: let y is equal to e raised to the power sin x. Using chain rule, we have dy by dx is equal to d by dx of e raised to the power sin x is equal to e raised to the power sin x into d by dx of sin x is equal to e raised to the power sin x into cos x. Logarithmic differentiation. Now we will learn the differentiation of the functions type. Y is equal to f of x is equal to u of x raised to the power v of x. First we take the logarithm on both the sides and then differentiate both the sides with respect to x. The process of differentiation is called logarithmic differentiation. Example: differentiate x raised to the power x with respect to x. Solution: let y is equal to x raised to the power x. Taking logarithm on both sides, we get log y is equal to x into log x. Differentiating with respect to x, we get 1 by y into dy by dx is equal to x into 1 by x plus log x is equal to 1 plus log x. dy by dx is equal to y into 1 plus log x. Name it as 1. As we know that y is equal to x raised to the power x. Put the value of y in equation 1. dy by dx is equal to x raised to the power x into 1 plus log x. Derivatives of functions in parametric forms. When the relations between two variables which are neither explicit nor implicit, but there is some link of a third variable with each of the first two variables, such relations are called functions in parametric form. The third variable is called parameter. To differentiate such functions, we use chain rule as given below. dy by dx is equal to dy by dt into dt by dx, provided dx by dt not equals to 0. Example: find dy by dx if x is equal to sin t, y is equal to cos 2t. Solution: we have x is equal to sin t, y is equal to cos 2t. Differentiating with respect to t, we get dx by dt is equal to cos t, dy by dt is equal to minus 2 sine 2t. Thus, by chain rule we have dy by dx is equal to dy by dt into dt by dx is equal to minus 2 sine 2t into 1 by cos t is equal to minus 4 sine t cos t by cos t is equal to minus 4 sine t is equal to minus 4x. Hence, dy by dx is equal to minus 4x. Second order derivative. If y is equal to f of x is a differentiable function, then its first derivative is denoted by dy by dx f dash x. Again, if f dash x, that is, the first derivative of f of x, is also differentiable, then we can obtain its derivative, which is called the second derivative of f dash x, that is, d by dx of dy by dx is equal to d2y by dx square or y double dash. Example. Find d2y by dx square if y is equal to x cube plus 5x square plus 19. Solution. We have y is equal to x cube plus 5x square plus 19. Differentiate y with respect to x. dy by dx is equal to 3x square plus 10x. Differentiate dy by dx with respect to x. d2y by dx square is equal to 6x plus 10. Mean value theorem. Rolle's theorem. 1. If a function f of x defined over the closed interval a, b is such that it is continuous in the closed interval a, b. 2. It is derivable in the open interval a, b, and 3. F of a is equal to f of b, where a and b are some real numbers. Then there exists at least one number c lying between a and b such that f dash of c is equal to 0. Geometrical interpretation of Rolle's theorem. Mean value theorem. If a function f of x defined over a closed interval a, b is such that f of x is continuous in the closed interval a, b and f of x is derivable in the open interval a, b, then there exists at least a real number c belongs to a, b, for which f dash of c is equal to f of b minus f of a divided by b minus a. The result of the theorem states that there is at least one point on the curve between P and Q where the tangent to the curve is parallel to the chord through the point P and Q, because the slope of the chord PQ is f of b minus f of a divided by b minus a, and the slope of the tangent at any point C, that is, x is equal to C, is f dash of c. Did you know? Gottfried Wilhelm Leibniz was a German philosopher, mathematician, and logician who has independently developed the differential and integral calculus. Summary. Let us summarize what we have learned. A function f of x is said to be continuous at a point x is equal to a, provided left-hand limit, right-hand limit, and value of the function are equal. Limit h approaches to 0 of f of a minus h is equal to limit h approaches to 0 of f of a plus h is equal to f of a. Suppose f and g be two real functions continuous at a real number a, then f plus g is continuous at x is equal to a. F minus g is continuous at x is equal to a. F into g is continuous at x is equal to a. F by g is continuous at x is equal to a. G a not equals to 0. The derivative of function fx is defined by f dash x is equal to limit h approaches 0 of f of x plus h minus f of x divided by h. The derivative of composite function can be written as d by dx of y is equal to d by dt of dy into d by dx of dt. This method of differentiation is also known as chain rule. Exponential function with base 10 is called the common exponential function. The derivative of e raised to the power x with respect to x is e raised to the power, that is, d by dx of e raised to the power x is equal to e raised to the power x. The derivative of log x with respect to x is 1 by x, that is, d by dx of log x is equal to 1 by x. To differentiate functions in parametric forms, we use chain rule. dy by dx is equal to dy by dt into dt by dx, provided dx by dt not equals to 0. Second order derivative is d by dx of dy by dx is equal to d2y by dx square. Rolle's theorem states that if a function f of x is continuous in the closed interval a, b and derivable in the open interval a, b and f of a is equal to f of b, then there exists at least one number c lying between a and b such that f dash of c is equal to 0. Mean value theorem states that if a function f of x is continuous in the closed interval a, b and f of x is derivable in the open interval a, b, then there exists at least a real number c belongs to a, b, for which f dash of c is equal to f of b minus f of a divided by b minus a.